to divide a polynomial by a monomial, divide each term of the polynomial by the monomial. So if I have a plus b over c, you just separate them. You separate them only when you're dividing by one term. You could have as many terms you want at the top. If you're dividing by one term, you can separate this a over c plus b over c. Of course, c cannot be equal to 0 because that would cause this to become undefined. And then we reduce each of these. Then write each quotient in lowest terms. Take a look at the example. Divide, we have a polynomial at the top of the fraction over one term at the bottom of the fraction. So we separate these. We write this as 10x squared over 5 minus 25x over 5 plus 35 over 5. Then we just simply reduce this. 10 over 5 would be 2. So the first term turns to 2x to the power of 2 minus 25x over 5. That results into minus 5x. And finally, you get plus 35 over 5 would be equal to 7. Now, if I had 5 here instead of 35, I'm going to write this down because I've seen this mistake many times by my students. So I'm going to give you another example here on the side. If I had 10x squared minus 25x plus 5. Instead of 35, if I had 5. This is another example. I'm still going to separate these as I did. I would have 10x squared over 5 minus 25x over 5. And the last term will give me plus 5 over 5. So when I reduce this, I've seen in past that my students reduced the first one nicely, 2x to the power of 2, and correctly the second one they wrote minus 5x, and they left it like this. Yeah, make sure that the last term is plus 1 because 5 over 5 is 1. So the last term would be plus 1. Don't drop that last term. So then we can check this answer by multiplying it by the divisor 5. So if you look at this, if I have what we are claiming is 10x to the power of 2 minus 25x plus 35 over 5, now we are saying that is equal to 2x squared minus 5x plus 7 over 1, really, right? So if this is a proportion. So if this is the right proportion, then we have 5 times this expression must be equal to 1 times this expression. If I cross multiply these, should be the same results. That's what they're doing here. They're saying 5 times this quotient here that we found. The divisor 5 times the quotient must be equal to 1 times that. So we can verify our answer by just simply cross multiply this. Dividing polynomials by monomials. There's a couple of more examples. Once again, we're dividing polynomial by one term, 4x to the power of 3. If I separate them into 3 terms and reduce them, get x to the power of 4 over x to the power of 3. Don't forget, we're going to use the properties that we learned to have a to the power of n over a to the power of m. We subtract the exponents, and everything goes to the top of the fraction over 1. So as you see here, you get x to the power of 4 over x to the power of 3 would be x to the power of 4 minus 3, which is equal to x to the power of 1. Now here would be x to the power of 3 over x to the power of 3. That would be x to the power of 0, or anything to the power of 0 is equal to 1. And you can see this reduces to 7/4. And here we get x to the power of 2 over x to the power of 3. If I want to write my formula here, see x to the power of 2 over x to the power of 3, that is x to the power of 2 minus 3 over 1. As you see, we get x to the power of minus 1. Now at the end, if you get the negative exponents, you want to make that positive by placing that at the bottom of the fraction. That's why this whole thing becomes 1 over x. That's why this x goes to the bottom of the fraction here. And that makes sense too, because if I have 3x x at the bottom of the fraction and 2 at the top, this 2 and this 2 at the bottom would reduces to 1, and you end up having 1x at the bottom of the fraction. But you should really look at it as following the properties we learned and change the negative exponents to positive using this property. Next example here, we separate them again. We get each of terms at the top of the fraction over a cubed b to the power of 4. We reduce them using this property and make sure that each term has a positive exponent.